Hey everyone, my name is Franco Patano. I'm a solutions architect here with Databricks. I live out in the Chicagoland area, and this is Data Collab Lab with Franco and Denny.
Perfect. And my name is Denny Lee. I'm also a developer advocate here at Databricks based down in sunny Seattle. Yes. If you don't know which session you're in the house. Scribd uses Delta Lake to enable the world's largest digital library. We're going to discuss with Scribd engineers on Delta tables and the transaction log. Yes, we're going to get geeky, so make sure you ask your questions in the Q&A panel. We're prepared to answer them. Now, saying this, QP, Tyler, why don't you introduce yourself so everybody knows who you are and what you guys are doing? We'll start with you, QP.
Sure. I'm QP. I'm an engineer at Scribd, and I'm really honored to be here to have discussion with everyone to talk about some of the cool projects that the data engineering team and core platform team has been doing in the past 2 years around Databricks, the cloud, and Delta Lake.
Thanks, QP.
I should
Tyler.
also add that QP is the only person I know that's actually read through the Delta Lake spec and understands the protocol. Has really gotten in deep with it. But anyways, I'm Tyler Croy. I'm the director of platform engineering here at Scribd. I lead the core platform team, which builds out data platform infrastructure, and the data engineering team, which builds a lot of the tooling and ingestion pipelines that sit on top of that platform.
This is awesome. Thanks, guys, for joining us today. I just want to let everybody know that Data Collab Lab now has an email address. So you can see it on the screen there, datacollablab@databricks.com. This is all about you bringing the world's toughest problems to Databricks and us trying to solve them live or talk about how other people solve them. So if you have things that you want us to talk about or to work through, go ahead and email us at datacollablab@databricks.com, and maybe it'll be on a future episode. I don't know. What do you think, Denny?
Oh, absolutely. So you asked some solid questions. We want to answer them. We're going to answer them in this format initially, but then later on, we'll probably even do it on YouTube Live. So that way you really can call us out. All right. So saying that, let's get this started. Tyler, let's start with you, just because we'd love for you to set the background first and tell us a little bit about Scribd and why you have, what's the world's largest digital library.
Sure. So Scribd in startup terms is actually quite an old company. I think it was about 12 or 13 years ago now that Scribd started. And Scribd's lineage is in document sharing. A lot of people may remember the era of startups that names. Scribd is one of them. Flickr and Scribd and Tumblr all came out around the same time. And we were all about sharing documents on the internet. Over time, that model has transitioned to where we expanded out of documents and included books and audiobooks and sheet music. And with our recent acquisition of SlideShare, that also includes presentations as well. And so when I joined Scribd in early 2019, we had this huge, enormous corpus of user-uploaded content, but also publisher content, and this really, really interesting and challenging data problem. And we just didn't have the data platform to allow us to do anything interesting with it. And so that's when I joined, and part of why we've invested in the direction that we've invested in and built up this platform engineering organization.
That's awesome. So you try to build this on your own previously. Can you tell us a little bit about that? Was QP involved? Like what did you got? What were you like working with before you kind of went down this journey to the cloud?
Let's call where we came from. Let's call that revision 0. Revision 0 was organically created. There's a data platform that existed when I joined Scribd that was largely built around this sort of legacy Hadoop HDFS Hive infrastructure. When I joined, we had Spark 1 running as well as Spark 2 and a number of other non-Sparky things running on this cluster. And it was barely meeting our needs that we had, at day one when I started, much less future needs or desired things that we wanted to do. And so the first order of business was really in 2019 evaluating, we can't do what we want to do today with this data platform, much less come up with new ideas of what we can do with this content. So let's go find a way that we can, build a platform that's going to grow to future unconceived of use cases. And that sort of set us down the road of, looking at the cloud, obviously, because we can go get a lot of stuff very easily in the cloud. In our case, our cloud provider, AWS, you may have heard of them. They're really, really niche, really niche cloud provider. But there's a bunch of things that were already built into AWS that we were interested in using. But then we discovered a lot of what Databricks had been up to at the 2019 Spark and AI Summit. And I remember this very clearly because it was in San Francisco and I didn't go. I could have gone, but I didn't go because I had other stuff I wanted to do. And multiple engineers came back from that session or from that event saying, we've got to do Delta Lake. Delta Lake. Like, that's all I heard about that event was Delta Lake. And so that's when we started to really invest in Delta Lake and look at the Databricks platform around it. And that sort of set us on this trajectory that we are on today.
That's awesome. So when you experimented with the cloud, obviously you probably would have looked at like S3, and maybe you were using, you mentioned Hadoop before, you were on HDFS. When you first tried experimenting with S3, did you run into any issues? This is like before you've kind of discovered Delta. When you were just kind of dabbling in, dipping your toe in, if you will, did you notice any problems with doing that?
We fortunately found Delta fairly early. We'd started doing some prototyping and investigations on how our existing workloads would work on S3 and AWS. And one of the big things that we had problems with is we still to this day don't have 100% clear understanding of how all of the workloads are actually utilizing storage at the bottom of the data platform or building, Spark on top of it. And frankly, I don't want to know. I don't really need to know. But as we dug into some of these use cases, we found people doing things, really interesting things, let's put them that way, with HDFS or with HDFS and Hive in concert, and these dependencies between jobs. And we've talked about this publicly on our tech blog. But when we started this journey, we had over 1,500 tasks that were running in our nightly batch workloads, that were doing things. What they're all doing, I don't know, but they're doing things. And there's a lot of pipelines that have this really tightly coupled relationship between the producer of data, so one job producing the data, and another job viewing that data. And sometimes those task dependencies aren't always very clearly defined in the orchestrator. And we're very concerned about the consistency on S3. So one pattern that a lot of organizations will use on S3 is to deploy S3 guard. But what was really exciting when we found Delta Lake is we had like a prototype internally of here's how we are going to guarantee consistency and availability of data on S3 with S3 guard and some other tooling and some patterns that we were going to bring in. And then we discovered Delta Lake. And we basically threw out all of this work that we were planning to do to ensure that we would have consistent reads and writes when we moved our HDFS-based workloads into S3.
Wow.
Yeah, we did have a prototype, but a lot of that prototype for what this was going to look like on AWS, which is sort of raw S3 underneath, basically got completely obviated by what we can do with Delta Lake, which is part of the reason why we're pretty big fans of Delta Lake, if you haven't surmised that already.
I don't think I have yet. Maybe we'll get
there. All right, let's switch more instead of like this back and forth. let's dive into the technical details. So let's think here. You talk a little bit about the fact that you did do this migration, but can either Tyler or QP tell us a little bit more about like how did you do that migration? You had a lot of these. It's my understanding that you had a lot of these workloads in HDFS or in Hive. How did you manage that transition?
QP, why don't you start talking about the workflow and the orchestration side, and then I can talk about some of the the underlying data things that we had to change for data engineering.
Yep. So I would like to mention that this is still a ongoing process. We have to go through, I think, more than half of the data already. So the first thing that we did was thinking of how a solution to migrate our workflow orchestration system to the cloud. We have a in-house built workflow orchestration system called DataPipe that it's more than a decade old and actually older than Airflow. And so the first decision that we made was to actually migrate everything to Airflow. And so that came with a bunch of interesting challenges. For example, the 1500 tasks that Tyler mentioned earlier does not work out of box with Airflow. Airflow would just die if when we tried the DAG on Airflow. So we had to do a lot of optimization on Airflow itself, and to make it work with the scale that we are at. And I'm very happy that the team worked really hard to also upstream all the optimizations that we did to the Airflow project so that everyone will get the same optimization we have implemented in-house. And so it's a very lengthy process. We basically migrate the data platform layer by layer. So the project started with migrating the output layer of the pipeline, which writes the data into external data stores like MySQL or any kind of online data stores like Elasticsearch. So we get that layer migrated, and then we work on the middle layer, which is all these nested task dependencies. And then at the end, we actually have planned to migrate the upstream layer, the input data layer, meaning the Scribd tasks and all the layers that's responsible for ingesting input from Kafka and other sources into the data lake. So that's how we plan out the migration process. So far, I would say it's been doing pretty well because the Databricks, the capabilities we get from Databricks, Elastic Cloud, and as well as really being able to spin up clusters really fast and being able to test all these codes locally for each developers to have their own develop workspace. That was a huge win in terms of productivities, and been really enjoying it so far.
That's awesome.
One of the things, like when we talk about like the layer by layer, that's like from the code standpoint. We also had to do that from a data standpoint as well. So one of the first things that we deployed was a bit of Spark code that one of the engineers on the data engineering team wrote, which is basically at the tail end of our nightly batch processes, after everything's been effectively written into Hive and persisted into HDFS, would go through the catalog. And for all of the tables that we're going to migrate, in essence, it's an rsync, but it's not actually an rsync that we're doing. But we would basically replicate that data into Delta tables that were in AWS. So if you think about starting from the back of a big ETL pipeline, at the back, we added another stage at the back of that, which is write to Delta Lake, right? So we're writing all this data at the end of the pipeline into Delta Lake. And then we were able to start to bring application workloads over into AWS and Databricks on top of that because the data was already there. One of the other things that I briefly alluded to, Franco, that we had all of these different types of workloads. For those that don't know, Databricks is a Spark platform. It's not a Hive platform. It's not a Yarn substitute. It's Spark, right? And so that meant all of the wacky workloads that were like just Hive queries or doing some old style Hadoop map reduce or Spark One, like everything has had to converge on Spark as a platform, which is beneficial for a lot of reasons, but it's also been a lot of work. And when we started to dig into that big graph of 1,500 tasks, we found that almost half of those tasks were basically these templatized Hive queries. And Hive query language is not quite the same as Spark query language, and we found some very interesting abuses of Hive as we're doing this evaluation. So one of the tools that we built, and I'm optimistic, I can't make any commitments, but I'm optimistic that we'll be able to open source this at some point, is we basically wrote the SQL runner tool that we use to take sort of our Hive query jobs in on one side and execute those as Spark jobs on the Databricks platform. And so that's also been a very big part of this, migration into the cloud, is we've had to sort of funnel everything into Spark in, one shape or another, which has been quite a challenge.
That's awesome. You say it was a little bit of a challenge. That that query runner sounds like some pretty nifty code. So I'll be following along to see if you open source it. But there's a couple of things there I kind of want to like dig a little bit deeper into. You mentioned you did this layer by layer, and then we're talking about a lot of Spark migrations. And I kind of want to ask, this means it's not an all or nothing type of migration effort, and can you talk a little bit about how like it was layer by layer, and how it's not like a dramatic one shot project? It actually can be done in phases. Can you talk a little bit about how that worked, or mechanically or technically?
So as QP mentioned, like this is definitely an ongoing project. As we like literally today, right now, our nightly batch processes are on both our legacy data infrastructure and on Databricks, from being driven from the same Airflow DAG. QP, do you happen to know like how far along, like what percentage, or some other heuristic of like how much we have running in
more than
Databricks
half
versus on? More than half.
Yeah.
Nice. We're farther along than I thought.
So this doesn't be an all-in migration effort. You can kind of peel off piece by piece, and you can kind of dip your toe in, see that it's going to work, and then you can start phasing it out.
Yeah. QP, could you maybe talk a little bit about the layered approach that we started?
So, there's one thing that I would like to point out, that why we went with this approach instead of like a fork and lift approach. We actually thought about that a lot at the beginning. And the reason we did with this layer by layer approach is we want to deliver incremental deliverables to our customers, internal customers. For example, the data sync process that Tyler mentioned earlier, which synchronized the HDFS data into S3 Delta Lake. Once we get that done, we were able to start push everyone to use Databricks notebooks for any kind of ad hoc queries, right? And that was immediately a big win for the team, because previously people were using Hive, Impala, using a Hill UI, and they were not. We don't have notebooks where people can actually share and collaborate with each other. So being able to just run ad hoc queries at the very beginning of this migration process was a big productivity boost for the whole engineering team. And we haven't even started migration at the time. We were only just doing data sync. So as we, then the next step was, as I mentioned earlier, was to migrate the output layer of the pipeline to Databricks. And that gives us the opportunity to actually play with different kinds of online data stores within the cloud in AWS. For example, we, at the same time, we also migrated the online MySQL data store into RDS in the cloud, and output from the data pipeline to RDS directly. And that also was a huge win for us. We were able to reduce latency for our online APIs, and basically got rid of the latency spike during the export process. So that was the main reason that we went with this approach, was really to give an incremental deliverables to the engineering team, and instead of let's wait for a couple months or a year before everyone can enjoy all the benefits that we get from the cloud and Databricks.
That's awesome.
Cool. So, oh, sorry about that. I forgot that I muted myself and was busy talking and forgot to do that. So this sounds amazing what you're talking about, QP. Well, what kinds of things have the consumers been saying about, basically using Delta and Databricks? Has their experience itself been better by using the platform now that you've started switching over, as you've been sort of calling out?
Yeah, I think at least from my point of view, the two biggest thing that I've heard from other developers are, the first one is being able to work on notebooks in a collaborative way, like being able to have a notebook that you can share with other people, and actually everyone is jumping into the same UI and collaborate on that. That was a huge win. It's really easy to share results. Like you can easily build ad hoc dashboards that way as well, and share with the rest of engineering, like with a couple clicks. So that was a big win. And then also we before doing that, we were using Impala for ad-hoc queries as well, and that was a lot faster than Hive. We were concerned about doing the same queries on Databricks notebooks and thinking that it would be slower with Spark. We read some blog posts from Databricks claiming that it's a lot faster than Impala, so we weren't really believing that, but actually trying that ourselves on Databricks, it did turn out that the same query actually even ran faster on Databricks than Impala. So that was also a huge win for us as well. And then the other the common thing that I've observed is in the past, when we were working with legacy on-prem data infrastructure, it's a lot harder to get new boxes, right? We basically have to file a Jira ticket to get a new machine for development purpose. So there were times where people were actually contending for, hey, can you give your developed machine to me so that I can run my code? Like that kind of discussion. With Databricks and the cloud, we don't have that problem anymore. Like anyone can just spin up as new machines they want and develop on the new work. So that was also
the number of times where developers would like the busiest times on the cluster when I joined the company were right around lunchtime, because all of the data scientists and anybody that's developing any models against the data set, they would basically launch all of their really heavy, expensive queries right before they would go to lunch, hoping that they would get their results when they came back.
Oh yeah, you're pulling back old memories on this one. Yes, where you're pulling off old Hive queries. Like this is a few years back now for me as well, but same idea, right? I'd go ahead and right before lunch, or more usually right before I left work, right? Because I knew it'd run overnight. Right. So just before I I just shoved to the cluster, just shoved a whole bunch of queries, let it run, and then hope. And then maybe I'd log in at midnight just to check, see if it's okay.
So as someone who helps to run the platform that supported that crazy behavior, that was the worst for us, because it would mean we would have these two really aggressive spikes in utilization on the cluster. One was at lunchtime, and then one was, like you said, right at the end of the workday on the Pacific Coast, when everybody's like, well, we'll see what I get tomorrow. And then everyone would be hammering the query at the same time. And one of the big things is, you mentioned with Hive queries, if you haven't used Hive before, one of the nice things about Hive from a user standpoint is you're basically leveraging all of the resources of the cluster to execute your query. From a systems management standpoint, that's the biggest problem with Hive, is that every user's query is going to try to command the resources of the cluster. And now that we're having users that are spinning off clusters for their own work, or when we launch jobs, we're launching clusters per job. That means we have a much more efficient compartmentalization of those resources. So not only are these queries getting faster, like QP mentioned, but it's also, to be honest, they're safer, in that there's no noisy neighbor effects that occur between jobs, which definitely happened in our on-premise infrastructure, which was a huge problem.
That's awesome. I'd like to pivot to another very common problem that I used to experience, and probably maybe other people have as well. The catalog, the metadata catalog. So you went from the Hive meta store to Glue. Can you tell us a little about that? How you managed it? How it worked out? How things are working now with that you've integrated Delta.
So we adopted AWS Glue Catalog, and it's gone okay. It's not my favorite part of the stack, but I don't know anybody who gets super excited. I mean, maybe there's people at Databricks that get super excited about catalogs. I'm definitely not a person that gets super excited by it. The big challenge that we had with the migration to Glue Catalog is that we had to maintain two catalogs, basically, because we're still, we've got 1 foot in our legacy data center and then 1 foot in AWS. We have to maintain both of these at the same time. And so we had to write some tooling to basically manage the catalog and the schemas that are being applied into those catalogs consistently. Because if you create a table in our Hive environment, and if you're expecting, and this is what most of our users have expected, that data is going to be synced into Databricks, that means we also have to make sure that that schema is applied and managed in Delta Lake, and that the glue catalog that you would be relying on is going to point to that. So we wrote another piece of code that I'm optimistic that we will be able to open source. There's no reason it shouldn't be open sourced. That basically, it's like active record migrations or liquid-based migrations for Delta Lake. But it obviously also is working with our H catalog and Hive. So we spent a fair bit of time writing that to make sure that from a developer standpoint, that we weren't spending a lot of time trying to manually manage multiple catalogs, that we just have this one single source of truth that's in a Git repository that defines, here's what the schema looks like for all of our catalogs. There is a slight nuance that we didn't understand about glue catalog when we started to use it. A glue catalog is one per AWS account. So if you have, if all of engineering, for example, is using one AWS account for their work, then you have one glue catalog for all of those teams. In our case, we actually use multiple AWS accounts for different teams to give people a little bit more of a sandbox, so they don't conflict with anybody else's work. But that sort of accelerated the need for automated tooling to manage these catalogs, because all of a sudden we've got a catalog that's associated with the applied research team and a catalog for the recommendations team in their AWS account. In a lot of cases, they're pointing to the same data underneath in Delta Lake, but they're in these different accounts in AWS. And so we have to, push changes to all of these different accounts, which can be challenging if you don't have the automation already.
Interesting. So, okay, let me switch off the catalog topic since you called that out, Tyler. And QP, I want to know a little bit about, and this is actually some of the questions that have been coming in from both LinkedIn Live as well as YouTube about how do you optimize manage the file sizes in your cloud, right? For example, when you have a lot of files, especially going to your S3 buckets, right, that potentially can increase the cost, right? So how do you optimize all this? How do you improve the performance so that way you can actually, in addition to having reliability to your data lakes, you can also have not actually help control the costs, that is.
Yeah, I can talk about this. So one of the big reasons that we chose Delta Lake was we want to use it as streaming tables as well to work with our streaming workloads. So as you can imagine, when you writing to Delta Lake from a streaming application, you basically creating a lot of small files, right? And over time, that will cause a big performance issue for you. Luckily, Delta Lake actually came with the optimize command that you can use to actually automatically optimize those small files for you and compact them into larger ones. So from a user point of view, it's actually really trivial. You just basically have to run the optimize command to optimize the data, and then everything will be taken care by for you by Delta Lake.
Perfect.
Awesome.
Well then, sorry, I just wanted to do a quick follow-up if that's okay. Related to this then is talk a little bit about the streaming and batch concept, right? The fact that you actually need to run those optimized jobs to handle the fact that you're streaming, handling both streaming and batch concurrently at the same time, right? Because that ultimately increases the number of files that you actually are writing into S3, right? You when you're streaming, there's all these small little files that you had alluded to earlier. So yeah, so yes, we use optimize, but then how do you manage all of this? I'm just curious.
Yep. So from the writer's point of view, right, they don't really care about optimization. Like they just write whatever data they want to the table, and you can do concurrent writes as well. And on the side, we also have a dedicated like optimized job that's orchestrated by Airflow that runs on a specific cadence. And this job, we actually have a configuration to configure like how frequent do we want to optimize for a specific table in Delta Lake. And that job is responsible to optimize all these small file problems in the background for the other writers. And so the writers, basically, they don't have to care about the small file problems. And this is safe to do because of the Delta Lake itself has MVCC. So it's safe to run an optimized job on the side while the upstream job is actually writing to the table at the same time.
That's awesome. So how has streaming unlocked value for your data workloads, and have your users responded to this type of architecture?
Man, I love a good manager question. Yes, let's talk about value. um, so when I joined Scribd, like streaming or real-time data was probably that was like that pie in the sky sort of moonshot initiative that we had started to work on. The way that most of our data customers traditionally have consumed data. So when I say data customers, I mean like product management or business analysts or people that are sort of downstream from these ETL pipelines. They would get their results basically tomorrow for whatever happened today in the best case scenario. Right? So the nightly has to run. If anything went wrong with the nightly, they might get their data 2 days from now. But what that meant for like an actual product manager is that if they wanted to look at A/B test results for a deployment that went out at 9 a.m. today, they would be waiting until tomorrow morning, or worst case, until Saturday morning, because this is Thursday. For people that were watching the recording. But with streaming, the goal that we had there is we want, as soon as data is created, we want to be giving that to the people that want that data to use it. And there's a couple of really interesting use cases that started to come out of the woodwork once we started to incorporate streaming more into the platform. The big one was totally unexpected, was around our ad hoc queries. Like we enabled all of these people to use Databricks notebooks to run these ad hoc queries, but because as QP mentioned, because we're like streaming to a Delta table, from the user's perspective, it just looks like a table. Like it's not this special thing. It's if you want to pull streaming data into your ad hoc workloads and you don't have Delta, you might be teaching users how to connect to Kafka topics or pulling it into some other intermediate store that they're going to query. But for our users, a Delta table that's streamed to versus a Delta table that's updated via the nightly batch, it's fundamentally the same interface, except one is obviously refreshed a lot more frequently and they see data from that. And so users, in a lot of cases, without even realizing it, started to get faster results because their tables were actually being streamed into as opposed to written from a nightly batch, which was when some people started to recognize that they got that superpower once we started to add some streaming data into the platform. They're over the moon excited. I think the fastest time from data generated to something being available in the platform that I've seen is about 9 seconds. And that's like 9 seconds from the event being created from a production web application to it being available for a Databricks notebook. And when you take that value proposition to somebody who's used to having like worst case 48 hours for their data, they're like, wait, what? What do you mean 9 seconds? That's not like it's like if you showed a spaceship to someone from the 1700s, like they almost can't even comprehend a tremendous amount of change that they just encountered and get to benefit from. So unfortunately, not all of our data is streaming. We do have a lot of data that streams through Kafka into different Delta tables. But there's some things like QP mentioned, scoops are at the top of our ingestion pipeline. Scoops, that's with SQOOP, if anyone's not familiar with it. It's just copying MySQL data into the data platform. That's not streaming, and that's still done on a nightly batch. And getting that data to be streaming is actually really, really hard. So we might not do it. But for the data that can be streamed, it's pretty sweet once it's streamed into Delta tables.
I'm just curious, are you by chance using things like trigger once or things like that so you can convert existing batch queries into much more like near real time, so that way you don't actually have to maintain all these different jobs? Admittedly enough, I don't think I've ever trying to do that with a scoop query, admittedly enough.
I will delegate this to QP.
Yeah, I think
fair enough.
So the team itself, we're actually busy doing the migration, but that's some of the optimization that we're looking forward to do in the next year. We can see a lot of low-hanging fruit for our data pipeline. And I can see that a lot of the batch jobs can be optimized into like streaming jobs or incremental processing jobs. That I think will give us like an order of magnitude improvement to our runtime as well. and including the data freshness. At the end, the user, I think, will benefit from this as well.
No, that's awesome. Actually, I'm going to add a little color to it if you guys don't mind. So one of the examples that was actually from Spark Summit last year was Comcast. And the reason I call this particular case out is because they went from something like 84 jobs down to 3 because they had all these batch jobs that they were trying to maintain. Because they converted to streaming using Trigger once, they got it down to 3 jobs. And in addition to that, they used 10 times less resources.
Yeah,
so
I actually saw that talk. I remember.
Yeah, exactly. So I figured as much. So I just figured I wanted to add a little color on that one. So yeah, my apologies. I'll get off the soapbox now.
just to set the record, it was 640 nodes down to 64. They had a 10x reduction in their EC2. Yeah, so that's the power of Delta. But if you want to learn more, definitely check out the talk. They definitely go into details on that.
Cool. Oh, sorry, Franco, go for it.
Hey, so we've kind of talked a little bit about Delta with the optimize command, a little bit about how it manages the files. But one of the other kind of really interesting engineering tools is caching, the Delta cache. How is the Delta cache helped with your ETL engineering?
So I don't think we have done like a comprehensive evaluation of that. But at least from my understanding, the most obvious effect that we had is doing ad-hoc queries, like enabling the cache versus not enabling the cache, made a big difference when you're doing ad-hoc queries on the data set we have. So we definitely highly leverage that a lot in our notebooks ad hoc clusters, where users get a lot faster queries through the caching.
And underneath the hood, the reason that is really, really powerful for ad hoc users, I'll take myself as an example. I'm not good at Spark SQL, like at all. And so every time I'm running one of these ad hoc commands, Spark is going and grabbing that data off of S3 and then pulling it into the cluster to process it, right? As I hunt and peck and try to get the Spark SQL query to do the right thing, each invocation, if I'm just grabbing that data off the local disk, it's definitely faster. Part of the reason why this is a little bit difficult for us to quantify, like we're relatively new. I say, less than 6 months. No, maybe it's about 6 months now because it is October already. About 6 months that we've been running a lot of our ad hoc workloads and increasing amounts of our automated workloads in Databricks on Delta Lake. There's so many low-hanging pieces of fruit that oftentimes where we see big performance gains are like these boneheaded mistakes that we've made along the way. Like one of my favorite examples was, I remember this one job where the user was inadvertently pulling an entire result set, which was like gigabytes of data, and then squeezing it through a UDF. And just not trying to pull the entire result set from a single partition and squeezing it through a UDF made a huge impact on our performance, and huge impact for their queries. And it's just like these very simple, like use the tool maybe a little bit better things have made the biggest dramatic impacts on our performance, because it is just a checkbox. And for anybody that's not used Databricks, when you launch a cluster, it really is like check Delta cache. We haven't needed or desired to do a really substantial bake-off of like using Delta caching versus not. We just turn it on. So, well, even like a 20% cache hit rate is still better than 0%, and it doesn't cost us anything to turn it on, and it's a checkbox, so we'll just check the checkbox. Done. And so some of those performance things where it's like, oh, if we just check this box, we might get better performance. We just check the box and assume that somebody has done the actual bake-off, on the Databricks side or somewhere else, and then we get the performance benefit from it.
That's great. I know I doodle with the boxes as well on the cluster manager. I'm going to try this feature. I like it with the new run times. It's like, ooh, a new beta runtime. Let's see how much faster my stuff is getting.
So let me switch a little bit more to the process around engineering, right? So outside of just clicking on checkboxes, that is, okay? I'm just curious how, and maybe I'll direct this to you, QP. How's Databricks helped with your engineering team, the ability to deliver? Don't worry, Tyler, I still want you to chime in. I just figured I want QP to talk, from instead of the manager talking first, I want the geek to talk first. That was all.
So like I said earlier, the biggest benefit we get is productivity boost. Like nowadays, I think everyone agrees that engineering time is way more expensive than whatever cloud resources that you'll be buying to run your app. So being able to save developer time, that's the biggest win for us. And yeah, the other thing is being able to leverage the latest technologies that's standard in the industry. Be able to use the latest version of Spark. And I have to say that Databricks have done a really good job at optimizing Spark. I think, although not all the optimizations are open source, but at least when we're using the Databricks platform, we get a lot of the optimizations that we needed to get the job done a lot faster. Like I said earlier, back in the old days, engineers have to compete for development machines. That was not the case anymore. Be able to collaborate on the notebooks, that was a huge win. And then the other thing is less about Databricks, but more about running your development workflows in the cloud, where you can actually scale to any machines you want to get your work done. Like if you need this work to get done faster, you just add more machines and it would get done faster. And so that was a big win for us as well. Yeah, I think those are the main things. I would have to reiterate that all of the engineers really love the notebook interface that Databricks provide, and I think that was also one of the main reasons that we chose Databricks from the beginning. Like we really love the collaborative notebook experience.
Well, then, actually, in addition to your linear scalability and the workspace experience, I'm just curious, were there any changes in how you basically developed your models as well? Yeah,
so we are actually working with Databricks on getting MLflow into production for our production use. There are some limitations, but we're actually working closely with the team, and we're looking forward to the upcoming improvements from the team. And right now, we actually are storing our models in MLflows, and we're also using it to do model checking as well for machine learning models.
That's awesome. So when I was originally looking at Scribd, and I was talking to Denny about this beforehand, I did my own research. I actually didn't really know a lot about Scribd, but I have been consuming, with quarantine and all that, and now with coronavirus, things, I'm home a lot more, and I have more time to read, to consume the written word either. And we talked about, is consuming an audiobook, do you call that reading? I call it reading. And I actually was talking to an old friend over the weekend, and I was like, oh, so I was reading this audiobook. And he's like, what are you talking about? And I was like, listen, man, just go with it. But anyway, so I've been consuming a lot more media, and I've been a Spotify user since, I don't know, the early 2010s when it first came out. And at this point, Spotify has had my likes and my data now for 10 years, and their algorithms, they're really good at knowing what I like, and they kind of queue up these automated playlists that kind of they find all the artists I like, and they even find new music for me, and I love it. I don't even listen to the radio anymore. Spotify does a much better job of finding the content I would like, and delivering it to me. Is Scribd doing anything like this for consuming the written word? And can you tell us a little bit about what you might be working on?
So Tyler, go ahead.
I think I can talk a little bit about the more product and business side, and then QP can talk about some of the technology that's underneath or that we're working on underneath. Recommendations is probably one of the most important parts of our future, I would say. Like what originally really attracted me to Scribd as a company is like the business relies on the data platform. The future success of Scribd is really, really intertwined with how well we can build out and scale and mature, our recommendations engines, our search models, our ability to process content and get that back to users that are going to find that compelling and interesting. And when I looked at some of the other companies that, when I was looking for a job at that point, the other companies that I was looking at, not everybody's data infrastructure is the same value to their business. The classic like bank type of infrastructure, there's a very specific purpose of what the data engineering team is there to do and what they're generating and what their output does. It's not really going to change the trajectory of the bank, right? With Scribd, because data is so core and the content, the books, the audiobooks, and the documents is so core to what makes Scribd valuable and what makes Scribd successful, there's this very short line between, if we make a better data platform, if I can enable that recommendations engineer to do a better whatever the hell they do, then that's immediately more success for the company. And so for us, or for me at least, the fact that recommendations and search are so crucial to the business, and that our work on the data platform directly impacts that very, very key functionality is really, really exciting. But it also means that we've got to do things right. No screwing around here. Anyways,
Well,
QP, you were going to say.
All right, just to cycle back a little bit to the technical side of things. So since this is a Delta Lake talk, I want to mention how Delta Lake enables us to build better recommendation systems. So as Tyler mentioned earlier, we have this nightly batch pipeline that runs every day. And you can imagine that if a user clicks on something or express a intent that they like this type of content, they will only get new recommendation the day after, right? And that's not good from a user experience. With data lakes, we can actually now stream these the user intent into our data lake system and into our machine learning pipelines, so that that's what we call like day zero recommendation. And now that we can actually react to user requests in real time or near real time, and then provide much better and much fresher recommendation to our users. And I think that itself, it's a proof that having the right technology will unlock all these possibilities to the engineering teams and product teams to build products that was not even possible before. So I think that was a big gain that we get from using Delta Lake as well.
That's awesome. I just kind of want to go, I want to kind of synthesize a couple of things that we've been talking about here. So you're telling me that you're starting to leverage more streaming technologies. That means that your data is getting refreshed faster, which means the ability for your analysts to query more up-to-date data, and analysts and scientists, any data worker, right? So their ability to get more fresh data has been increased. But not only that, but with SQL and with all of the programming languages that we offer on the platform, so you can use Python, Scala, SQL, R, but now their ability to consume that data, because the Databricks runtime is more efficient, we have things like delta caching, that they're not only able to get the data latency, so the refresh rate of the data, but they're actually able to query the data faster. So their ability to derive insight and take action is significantly improved with this platform. Is that correct?
Yep, and using Spot Streaming, you can build reactive workflows, right? You can actually react to the data as it comes in and provide recommendation to the user, and that was not possible before with the batch pipeline.
That's awesome. So no more waiting for lunchtime or the end of your workday to execute your query.
Yep.
That's awesome.
Cool. All right. So by the way, we've got about maybe 4 minutes left for questions. We've done our best to try to answer questions live, by the way, using the Q&A as well as YouTube, as well as LinkedIn. All right. So we were in Zoom, so we've been trying to do all as much as we can. But QP, we got a perfect one for you here. Okay. One of the questions that actually had been off the side, but I figured you'd actually do a great job explaining it, is that to get delta transactions, right, do you not need to copy the data? It was the question was like an understanding from one of my previous sessions. I was explaining that in some cases you need to copy the data, in some cases you don't. Like, for example, in-place conversions, if you want to convert your parquet table into delta, you don't actually necessarily need to copy the data because you can just do an in-place conversion. But let's talk about the transaction log a little bit. Why am I constantly copying data? And you can just go from there.
So just to make sure I understand the question. So this is talking about migrating to Delta Lake tables or using existing Delta tables?
Using existing Delta tables. So
Okay.
in other words, I answered the first part, which is the in-place conversion does not necessarily require the copy. But now let's talk about why do we talk about copying when we of files when we use Delta Lake?
So it depends on the usage pattern. So if you're doing append only, like if you're only adding new data, then there's no copy involved. So what Delta Lake really does, from my point of view, is it provides it under the hood. Actually, the main thing it does is to look up like what's the list of Parquet files that you should read for the time that when you requested the table. So so that you can get a consistent view of what the data is in the table, right? So what it does really is to resolve the list of Parquet files that the Spark application have to read. And if you're only doing append only, then you're just adding new files to the list, right? And that's fine. Copy files happens when you have to do compaction. So like we discussed earlier, when you have to merge small files into one, that's when you have to copy those small files into one big file, right? That's when copy file happens. Or it happens when you're doing upsert, meaning where you want to update a couple rows in a single Parquet file. Then you have to copy the whole Parquet file and then update with the updated version and write the new version. And then delete the, basically in the transaction log, it managed the history so that it knows that the old Parquet file, we don't have to read them anymore. We just, for all the new transactions, we'll read from the new Parquet files. And that's when the copy happens as well. So it really depends on the usage pattern that you have in the application. If you're doing append only and your application already managed the compacting logic, then realistically, you don't have to do any copy.
Rock on. Well, then let's go ahead and for our final question, just because I want 2 minutes left so we can do the final little close down for Franco and myself. You've talked about a lot about the appends. Well, let's talk about append versus merge when it comes to concurrent writers or readers on a single Delta table.
Mm-hmm. So when you're doing concurrent writes with append only, it's totally fine. Like you don't get conflicts at all. So under the hood, Delta is using optimistic concurrency control, meaning that all the writers try to write to the table as if there is no conflict. And when there is a conflict, then they try to resolve the conflict. So when you're doing append only, there's not going to be any conflicts. Like when they retry, they will just add the new file to the list. So when you're doing upsert, there could be conflict depending on the application logic. So in some cases, you might actually get an error that you have to handle it at the application level. But sometimes if the conflict can be resolved, Delta Lake will also resolve the conflict automatically for you as well.
Perfect. Thanks very much, QP. I apologize in advance for everybody who had asked questions, but we weren't able to answer them. We are still trying to balance all the 3 different platforms right now and resolve that. Before you guys go, since we've got 3 minutes left, I did want to go ahead and do a quick call out before Franco and I thank everybody for attending, that is. But the quick call out here actually is on next, excuse me, next Tuesday. There's the next session that we're going to have here on the Data and AI online meetup will be a tech chat from BI to Lakehouse, part 2, Electric Boogaloo. No, there's no reason why we actually called that out. We just figured we would go do that. But yes, it's a session between myself and Simon Whitley. We are a bunch of Microsoft SQL Server geeks that have now wholeheartedly been in the realm of lakehouses. So we would love you to come to that session. You can definitely ask questions. And this time we might actually answer them because middle enough, Simon and I had too much fun the last time. So we were busy telling stories and forgot to actually answer some of your questions. We apologize for that. So Tyler, I also know that you want to definitely do a strong call out to the Scribd Technical Engineering blog. By any chance, can you, QP or Tyler, can you go ahead and post it on and then and do your shout out, please?
I I can talk about it. I don't know where you want me to post it, but just at tech.scribd.com, we've actually written a lot about this process, including some more of the details of I'll say the benefits and challenges we've had as we've adopted Delta Lake. If you just go check it out, QP's got a lot of really good content that he's posted as well around our migration to Airflow and some of the work that we've done there.
And then we have a lot more awesome blogs coming up. So make sure to click upvote and subscribe.
Make sure to like and subscribe.
Yes,
et cetera, et cetera.
Smash that like button, fam, as all the
Exactly. Click on it, boys and girls. All right, Franco, take us out, my friend.
Me? All right. Everyone, thank you for joining us today for the Data Collab Lab. QP and Tyler, thank you again for joining us today and telling us all about your journey and your phased approach to your migration and how Databricks and Delta Lake have been helping you out. I just want to call it out again. If you have tough problems you're trying to solve and you need some help, Data Collab Lab at databricks.com. Email us your questions or your issues, and we'll collaborate together, maybe an episode where we invite you on and we'll figure it out together. Thank you. QP, anyone else want to do an exit?
Yeah, thank you very much.
Yeah, thank you. I'm having a lot of fun.
Perfect. Well, then again, thank you very much, everybody. I want to see you next Tuesday so you can go make fun of myself and Simon. Otherwise, again, thanks QP and Tyler. Franco, Denny, we're both out.
All right.
Bye, everybody.
Bye. Have a good day.